Hello. In this video, we're going to go over properties of exponents. The main thing that we have to remember is this chart right here. And let's blow this guy up a little bit and put this over here. So the main thing to remember here is when we are multiplying exponents with the same base, the exponents will add. So check this out. 3 squared times 3 to the 5th is equal to 3 times 2 plus 5. We add those exponents. When I have an exponent to an exponent, they multiply. So in our example, 2 to the power of 3 to the power of 2 means 3 times 2. Now we can also distribute our exponent to everything inside of a parentheses. So you can see 4 times 3 to the power of 3. That 3 applies to both the 4 and the 3. A negative exponent's a little tricky. All that means is it will move something from the numerator to the denominator or denominator to numerator. For example, if I write 5 to the negative 2, it becomes 1 over 5 squared. Or if I have 1 over 5 to the negative 2, it will become 5 squared. It moves vice versa accordingly. So you can see that when you put the ones over them. Next, a zero exponent always means it goes to 1. When we have exponents above one another in a division setting, they will subtract, and the same thing type of distribution will apply. So let's jump into our examples that we have here. First example, we have 81 squared times 9 to the 4. The first thing we need to do is create the same base. So what I know is that I know 9 squared is equal to 81. So I'm going to change 81 to 9 squared and leave that exponent that was originally there still there. The 9 to the 4th still remains. Now I see I have an exponent to an exponent, so I'm going to multiply those guys. 2 times 2 is 4, so we have 9 to the 4 times 9 to the 4. Now we have the same base being multiplied with exponents. The exponents will just add, and that is it. That's what we get. Let's try the next example. The next example, the next example, we have negative exponents. So we're going to have to move the negative exponents first. So what we're going to do is identify the negative exponent and move it where it needs to go. So the numerator, if it's negative exponent, comes to the denominator. If it's in the denominator, the negative exponent comes to the numerator. So let's put that into action. So first we see y squared remains, doesn't go anywhere. And we see this y negative cubed comes up top to become positive cube. Same thing over here. This x remains. And then this x cubed came down. So it's negative and now it's positive on the denominator. Now we see, again, we have the same base and exponents. So therefore, we're going to add them, right? So 2 plus 3 all over x, 1 plus 3. Don't forget that there's an invisible 1 there, even though it's not written. And then our final answer is y to the 5 all over x to the 4 in this case. Last example, we see we have 27 cubed, 9 squared. We have to change the base. I know that 27 is 3 cubed. Make sure you leave your 3 there as originally put. 9 is 3 squared and leave your squared there as originally put. Then you can just distribute those exponents. And basically we have, remember, an exponent to an exponent, so we'll multiply. 3 times 3 is 9. 2 times 2 is 4. Now we have quotients of powers, and we see we have the same base with exponents dividing, so they are going to subtract, and we'll get from 3 to the 5. Another way to think about this, if you don't want to go straight into subtracting, there's another alternative. The alternative is to think about it like this. There are 9 3s on top, 3 4s on bottom, all that being multiplied. Which one has more? Well, the top has more. And by how many more? Well, by 5 more. So basically, if you were to write this out, is that this cancels a bunch of times, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. What happens is these cancel, because what's on same and on bottom, they cancel. And we're left with whatever's there. 1, 2, 3, 4, 5, 3 to the 5. So either of those work. Some students prefer the subtraction, some prefer the cancellation method of which one is more. Other than that, if you have any more questions, please shoot me an email.